Software construction is a software engineering discipline. It is the detailed creation of working, meaningful software through a combination of coding, verification, unit testing, integration testing, and debugging. It is linked to all the other software engineering disciplines, most strongly to software design and software testing. Software construction fundamentals. Minimizing complexity. Reduced complexity is achieved through emphasizing the creation of code that is simple and readable rather than clever. Minimizing complexity is accomplished through making use of standards, and through numerous specific techniques in coding. It is also supported by the construction-focused quality techniques. Anticipating change. Anticipating change is supported by many specific coding techniques. Communication methods, such as standards for document formats and contents, programming languages, platforms, tools, such as diagrammatic standards for notations like UML. Constructing for verification. Constructing for verification means building software in such a way that faults can be ferreted out readily by the software engineers writing the software, as well as during independent testing and operational activities. Specific techniques that support constructing for verification include following coding standards to support code reviews, unit testing, organizing code to support automated testing, and restricted use of complex or hard-to-understand language structures, among others. Standards in construction. Standards that directly affect construction issues include use of external standards, the standards for construction languages, construction tools, technical interfaces, and interactions between software construction and other disciplines. Use of internal standards, the standards which may be created on an organizational basis to support coordination of group activities. Minimizing complexity. Anticipating change, and constructing for verification. Managing construction. Construction models. Numerous models have been created to develop software, some of which emphasize construction more than others. Some models are more linear from the construction point of view, such as the waterfall and staged delivery life cycle models. These models treat construction as an activity which occurs only after significant prerequisite work has been completed, including detailed requirements work, extensive design work, and detailed planning. Other models are more iterative, such as evolutionary prototyping, extreme programming, and Scrum. These approaches tend to treat construction as an activity that occurs concurrently with other software development activities, including requirements, design, and planning, or overlaps them. Construction planning. The choice of construction method is a key aspect of the construction planning activity. The choice of construction method affects the extent to which construction prerequisites are performed, the order in which they are performed, and the degree to which they are expected to be completed before construction work begins. Construction planning also defines the order in which components are created and integrated, the software quality management processes, the allocation of task assignments to specific software engineers, and the other tasks, according to the chosen method. Construction measurement. Numerous construction activities and artifacts can be measured, including code developed, code modified, code reused, code destroyed, code complexity, code inspection statistics, fault fix and fault find rates, effort, and scheduling. These measurements can be useful for purposes of managing construction, ensuring quality during construction, improving the construction process, as well as for other reasons. Practical considerations. Software construction is driven by many practical considerations. Construction design. In order to account for the unanticipated gaps in the software design, During software construction, some design modifications must be made on a smaller or larger scale to flesh out details of the software design. Construction languages. Construction languages include all forms of communication by which a human can specify an executable problem solution to a computer. They include configuration languages, toolkit languages, and programming languages. Configuration languages are languages in which software engineers choose from a limited set of predefined options to create new or custom software installations. Toolkit languages are used to build applications out of toolkits and are more complex than configuration languages. Programming languages are the most flexible type of construction languages, which use three general kinds of notation. Linguistic notations, which are distinguished in particular by the use of word-like strings of text to represent complex software constructions, and the combination of such word-like strings into patterns that have a sentence-like syntax. Formal notations, which rely less on intuitive, everyday meanings of words and text strings and more on definitions backed up by precise, unambiguous, and formal definitions. Visual notations, which rely much less on the text-oriented notations of both linguistic and formal construction, and instead rely on direct visual interpretation and placement of visual entities that represent the underlying software. Coding. The following considerations apply to the software construction coding activity. Techniques for creating understandable source code, including naming and source code layout. Use of classes, enumerated types, variables, named constants, and other similar entities. Use of control structures. Handling of error conditions, both planned errors and exceptions. Prevention of code-level security breaches. Resource usage via use of exclusion mechanisms and discipline in accessing serially reusable resources. Source code organization. Code documentation. Code tuning. Construction testing. The purpose of construction testing is to reduce the gap between the time at which faults are inserted into the code and the time those faults are detected. In some cases, construction testing is performed after code has been written. In test-first programming, test cases are created before code is written. Construction involves two forms of testing, which are often performed by the software engineer who wrote the code. Unit testing, integration testing, reuse. Implementing software reuse entails more than creating and using libraries of assets. It requires formalizing the practice of reuse by integrating reuse processes and activities into the software lifecycle. The tasks related to reuse in software construction during coding and testing are the selection of the reusable units, databases, test procedures, or test data, the evaluation of code or test reusability, the reporting of reuse information on new code, test procedures, or test data. Construction quality. The primary techniques used to ensure the quality of code as it is constructed include unit testing and integration testing, test-first development, code stepping, use of assertions, debugging, technical reviews, static analysis. Integration. A key activity during construction is the integration of separately constructed routines, classes, components, and subsystems. In addition, a particular software system may need to be integrated with other software or hardware systems. Concerns related to construction integration include planning the sequence in which components will be integrated, creating scaffolding to support interim versions of the software, determining the degree of testing and quality work performed on components before they are integrated, and determining points in the project at which interim versions of the software are tested.